Welcome, and thanks for tuning in. My name is Matthias Oppelt, and I'm leading the Simulation Center in Siemens Digital Industries. Let me take you on a journey through the virtual world within the process industries, from the first idea of a new product all the way until an optimized production. Welcome to our holistic digital twin ecosystem. After the idea and definition of a product, chemical and process engineers start to design the desirable production processes. The digital twin of the process evolves, supporting the design of the process and equipment. In our case, this detailed chemical simulation is supported with the advanced process modeling technology embedded in our gPROMS portfolio. gPROMS supports you from the steady state to the dynamic process design, providing a lot of optimization power to find the best design possible, and helps you to design the operating policy. Now, as the best process design is found, the plant needs to be designed and the digital twin of the plant evolves. Supported by our integrated software portfolio for process industries. In gPROMS, the engineering of the plant covers, for example, process flow diagrams, process and instrumentation diagrams, as well as electrical and instrumentation planning. A real plant is equipped with a lot of hardware, which also needs to be configured. Same with the plant topology. And not to forget about the automation systems, which needs to be designed and later engineered. Greatly, information from the planning phase in gPROMS can be reused in our process control systems like SIMIT PCS7 and PCS Neo. Thus, the automation engineer gets a head start to her or his DCS configuration. Supporting the automation engineering, testing, and training of the later plant, the third digital twin evolves in SIMIT. It serves as a virtual replica of the real plant, being able to be controlled by a real control system to perform detailed checkout through the engineering and virtually commission the control system, to keep the on-site commissioning phase to a minimum. SIMIT therefore simulates the plant on 3 levels. From simulating the process behavior via detailed modeling of the device behavior, meaning to represent the behavior of actuators and sensors, until the signal level, which are the inputs and outputs of the control system. The real controller can be used in a real hardware setup with our SIMIT unit, called hardware in the loop. Or we can also emulate the controller by our SIMIT virtual controllers to run a software in the loop setup. Whereas the real controller is a real controller which will be used in plant operations, the virtual controller supports functions like a virtual time and snapshots. Further, plant operators need to be trained in interaction with the control system and the basic processes to give them a head start to production. The simulation system can also be developed further into an operator training system, fostering the know-how development for the control room operators, but also the field operators can be trained in addition or in combination by using gPROMS Walk Inside as immersive training simulator. The SIMIT digital twin can then also be used during the operations to validate any control system change before the deployment into the real plant. And finally, the gPROMS process twin can be combined with the SIMIT twin to enable high-fidelity operator training environments, including the full chemical process representations. In addition, during the operation phase, also the gPROMS process twin can be deployed for operational optimization, being connected to the real plant and being able to tune itself to match the real plant state as best as possible. Acting as soft sensor, the model can measure values that could not be captured, for example by real sensors, due to intense heat in the equipment or extreme physical circumstances. Further, monitoring of the process by the comparison with simulation values from the digital twin becomes no longer a utopia. And as the model is not limited to real-time and physical circumstances, the model can also be used to calculate and predict future states. To improve operations, for example by real-time optimization and advanced process control solutions like nonlinear model predictive control. All these digital twins serve one main purpose: to help the real production to perform even better, more safely, and more sustainably. We bring your digital twin to life to generate significant productivity gains across the whole life cycle within the process industries and beyond. Stay tuned to learn more about our holistic digital twin ecosystem.
Siemens, ingenuity for life.